You should be videotaping everything they say for the people who are not here.
Thank you for noting that.
I didn't
You think everything's circular is an engine? The mom's an engine?
I think it's important for this
Closer to them when you.
which was once the fastest man in the world, the side man. I don't know if you guys seen him before. Know what I'm talking about. He's basically the father of the car crash investigation, and he would not be able to do that nowadays. But from the data we gathered from his testing, we're able to determine through an X-Y axis on what a human body could sustain without, killing the person. I have a bunch of other pictures, but maybe during the class I'll show you some other ones. Really interesting stuff. This right here, through that data, we're able, algebraically, we're able to determine that. By the way, do we have any pilots here? Anybody flies? Okay. I'll use some terminology, and I have to backtrack a little bit, maybe explain some things. With the package you guys are going to be given, you're going to have a POH, Pilot Operating Handbook, depending on the site, weather, toxicology, autopsy, whatever that site has available for that. We don't have everything for each one of the sites, so you have to work through that. And doing this algebraically, like I was saying, we get the distance of the scar marks, the depth and the distance, and through that we could determine at what angle and other things with that. By the way, we have graduate students here that are welcome to chip in, chime in, if you have any suggestions, whatever. Let's swing around down this way. Unfortunately, Bill Waldock, for the amount of time you guys are going to be here, he's not going to be covering all the components of the investigation. First thing you do is coming down here, you have to keep your hands in your pocket and not have any preconceptions of what went on, okay? You got to put that to the side and come out here and look at the big picture. Find the four corners and systematically go down. Okay, was there a fire? Was it post-impact, post-crash or not? Can somebody tell me the three things you need for your fire? Yes, exactly. Thank you. So you have to determine that. So looking at this particular, by the way, whoever's doing this site, you're going to have some freebies here. Was there a fire here? No. Okay. Another thing that you need to point out that I'm not sure if Bill's going to cover this or not is the propellers. What you need supporting evidence for. You just can't come out here and look at the propeller, know whether this engine had full power or it was an idle. And some of the things that he goes over, and that's the whole class in itself, whether the propeller is bent back, forward, twisted, or it's just a tips. Something to take into consideration is the wings. See how they're folded forward? There's also hydraulic bulging on the wings, and you can tell there's fuel in there, but there's not an ignition source. I'm not going to go into details why. That's for you guys to determine. And you see the rivets here, how they were popped out. Okay, also something that's misleading is the controls, the cables that go through the aircraft in the back. If you see that tear on top there, that is a cable basically. This is called a scorpion effect. So the tail's over here, and the cable cut the tail there. There was some decapitation here, and okay, that's all I can say with that. I'm gonna Have any suggestions?
Sounds good. Sounds good.
Let's see here. Do we have enough time to compare this to another site?
Yes.
Okay, let's just go down this.
I'll give you a 10 and 5-minute warning.
Okay, thank you.
Thank you.
You have weight of the engine. Pulling.
Could you explain what the name of this site is? What kind of plane it is?
It's used.
Tractor. It's an air tractor. It's used for aerial application of pesticides, stuff for crops.
I'd like to compare this site to Site 1, which is that. Something to point out also, a lot of the safety elements come from aviation. I'd be introducing vehicles for safety. Just looking at this here. In racing specifically, the rollover cage. In talking to that, also Bill goes over what they call occupiable space. I'm not sure if you guys seen individuals such as contest, go to first floor, drop it, you got to put some cushion around it, and, you know, you guys know what I'm talking about? You guys confused it. Okay, so this is pretty much the same thing, but for the pilot. So looking at the crunch zones here, I just look at it like a sponge. It's going to absorb a lot of the energy. Also, with this here, with the engine, you have to take into consideration it's misleading, like I was talking at the first site. It pulls a lot of the controls, wires, and everything that's attached. But it does get, sometimes it gets attached, sometimes it doesn't, but it goes forward. And doing that, it's misleading because it's pulling a lot of the controls. So if you go, there's a specific site you guys are going to be working on that the controls might be misleading. So you got to take that into consideration. Such as the throttle. Okay, so another thing to point out is whether some of the things you guys can see on that side over here, the bullet holes on that there. This was sitting around for a while. Determine what is part of the crash and what is not part of the crash. For instance, the NTSB works on 300 to 400 individuals total. It's not that much. So they outsource a lot of this to the nearest airport where there is a crash. First responders and that. There's a whole chain of events with that there. My point is, once they go to the crash site, they have to transfer it somewhere, so you can't be going down the freeway or whatever with the wings out there. So it has to be cut and everything. You have to determine if it's part of the crash or not. And it's pretty obvious if it's nice, clean cut. The Caravan has that, by the way. Who's working on the Caravan? Okay, you'll be able to notice that tell. So
CJ does as well.
CJ, okay, that's the one we just passed over.
And also on the damage, you can get people, like salvage people, pulling it out of like wherever it's at. Say they're carrying a propeller and they drop it and they put a big old nick in it or whatever, and it's just you got to determine whether it's from the crash or from them.
Also, if there's a fire, there's different characteristics to the metal. Think of it as wax from a candle. It's going to be dripping. You know, you'll see that there, 401. And also, if the fire happened prior to crash, there's like a feathering to it, and you'll notice that also. We'll point things like that out for each specific site. Unfortunately, we don't have that much time today to go to different sites, but that's a general thing for that.
Yeah, and if there's any tips I want to give to you guys about accident investigation, you know, Mr. Adolfo has mentioned it. You know, you get to a site and you feel like, oh my gosh, this is fire, this is this, this is that. The most obvious might not be the cause of the accident. You know, that's what you should know. You have to think outside the box. And should you be working for NTSB investigating an accident, there are different protocols that you have to follow. You just don't see a plane crash, you kind of like, oh wow, I work for the NTSB, I'm just going to go to the crash site and start investigating. There are a lot of paperwork because depending on the aircraft, take for example Delta Airlines, you know, one of their plane crashes, you know, you have to get, you know, what you call chain of custody forms. You have to talk to NTSB, you have to, the FAA wants to be there. The airline corporation, they want to know why their plane crashed at that particular spot. So it's very important that as you walk through this crash lab, you think outside the box and don't look at the obvious, just think and ask yourself, you know, if this did not cause the accident, what might likely be the cause of this accident? That will give you more opportunity to explore than being too specific, finding answers like that.
That brings up something also. There's, I'm not going to mention what site it is, but you guys are going to be working the site, and there's a red herring. Just keep that in mind.
Explain to them what a red herring is.
Okay, red herring is, for instance, if you're doing math, the instructor gives you some extra numbers that have nothing to do with the problem. I think you guys know what that red herring is. Who knows what a red herring is? Just throw you off basically to see if you actually know what's going on with the problem, the situation. Any questions?
So tomorrow they're actually going to go to their individual sites. Can you talk to them about the very first things you do when you walk up to a site? What is the procedures, the generic instructions?
Okay, well I mentioned that earlier. Go to the site and you find the four corners. Like I was saying, you know, determine if there was fire, if it happened prior to the crash, post crash. Got any suggestions on that? I kind of mentioned all these things already.
Yes, I think one of the things you want to understand first if the site has been contained.
Yeah.
Because sometimes, you know, when an airplane crashes, you know, there are, you know, fluid gas, you know, out there. You want to make sure that the site has been contained because the cause of the flight might not be electrical fire, but when you start having, you know, jet fuel pour out of the airplane and there's an electrical spark, it might cause the secondary effect of the crash, which is fire. So you want to ask yourself one question: has the site been contained? Whose permission do I have to go into this site? Do I have the right paperwork to go in there? And some airplanes are made with different materials, some aluminum, some composite material. You have to understand what materials you'll be working on as you investigate the crash. Other things you want to understand is the terrain. Take for example, here, you know, we have turns, you might have snakes everywhere. You want to understand what predator we have in that area that you will have to deal with. You want to know the weather conditions. If you deploy your men on site to start investigating this crash. And you also want to know who is in charge of the crash site, because you don't want to go down there and disturb the evidence you have down there. It's worse. Once you disturb the evidence, then everything has been, what's the right word here, compromised. So you have to start looking for secondary sources to infer as to the possible cause causing the accident. So those are the things that I think you should be aware. Be aware of the material of the aircraft that you'll be dealing with. Make sure that the site has been stabilized to ensure that you don't accelerate further destruction of evidence.
Just one thing to point out, just remind me, in the real world, this is pretty much set up from accidents through pictures, and we try to place them exactly how they were when the accident happened. In the real world, you would wear what you call PPE. personal protection equipment. And depending on the area, like Prince was saying, type of jackets, just the clothes you're wearing altogether to protect you from born.
Bloodborne pathogens.
Thank you. There's blood, body parts, you know, depends on the situation again. So the only PPE you guys are going to be wearing is gloves to protect you from sharp objects and that, but you still got to take into consideration, you know, you don't really have to be picking parts up, but, you know, just having to, you know,